Okay, here's the final question on homework 4 about nodal analysis, problem 6. And this one is a little scary in that we have an op-amp here. And just to remember what that means, and you can assume that it's an ideal op-amp. So there's a few things that tells us. One thing that tells us is that the input current on the negative and the positive inputs, I minus and I plus, are both equal to 0, right? So it has, I would call that infinite input impedance. There's no current flowing in there. So if we do nodal analysis, or if we apply KCL, that means we don't have to account for any current flowing into the negative input or the positive input. Okay, so let's have a look at this. What are we doing? Well, we've got to find the nodes. So let's have a look at the nodes. There's a node here at node A, there's a node here at node B, and there's a node here at node C. One thing I can see immediately is that we have a voltage source connected between one of the nodes, node B, and the reference node. Okay, so that means we have at least one KVL equation. And then the other one, I think the equation at node A is going to be a KCL equation. Okay, and then the other KVL is to do with what we talked about, the other effect of or the other property of an ideal op-amp, and that is that the output, remember, the output voltage is equal to the gain times V plus minus V minus. And the ideal is that G equals infinity. And what that says is that G plus equals V minus. Okay, so in this case that means that VA equals VB, or VA minus VB is equal to 0, or VB minus VA is equal to 0. Maybe that's a better way to say it, because it's VB is the positive input here. Okay, so let's have a look at what that means. That means that we have two KVL equations and one KCL equation. The KCL equation is going to be for node A, and that's going to be, what's it going to be? It's going to be IS, which is 25 microamps, so that's that. And then the current flowing in this way is going to be V out minus VA on R1. Okay, so that's that. And R1 is, well, R1 and R2 are both the same, 18 kilo ohms. So there's our input current. There's no other currents flowing into node A, so we've got KCL at A. The KVL at B, because the positive side of VS is connected to reference and the negative side's on the other side, that means we're dropping whatever the value of VS is, which is 4 volts. So that means VB is 4 volts. And then, as I said, the op-amp KVL is VA minus VB equals 0. We can then plug all of those into an equation, although we could probably do it directly. We already know that VB is minus 4 volts, so VA has to be minus 4 volts, and then we can just rearrange this equation in order to get what the output voltage is. Okay, so V out is going to be 18,000 times 0.40, I think it's 4 zeros, yep, 25, and then in fact that should be V out, it's going to be minus that, and then plus VA, which is minus 4, so that's minus, try that again, 4 on 18,000. And that should give us that number there, minus 4.475. And then the thing we're actually interested in finding is the output current, and the output current is nothing more than V out on R2. So the answer we get for that is just, and again, I haven't even bothered to actually do the calculation, I've just put V out on R2 there. And that is how to do question 6. That is homework 4 done.